Well, good morning, everyone. Sorry I can't be there today, but I suppose one advantage is that you can just look at the pictures instead of having to look at me. And also, I don't have to face any difficult questions at the end. I've been asked to sort of set the scene, really, for this look back at the weather of 2019, to sort of give the broad context for the more detailed discussions that you're going to be hearing from the other speakers during the day. From my point of view, I think certainly from the media side of things, it seemed that weather was hardly ever out of the news in 2019. And maybe that's not surprising when you look at the combined impact of the various severe weather events. So the graphic here is showing the cost of extreme weather events across the world during 2019, adding up in total to around $100 billion worth of damage. And we've got three categories. So we're looking at floods, storms, typhoons, hurricanes, cyclones, etc. That's the sort of yellowy orange colour, and then fires in red. And of course, the one that jumps out immediately is this $25 billion from California wildfires during the latter part of the year. But to me, what really comes out of these figures is just how sensitive they are to location. Now, those fires, of course, in California burnt an awful lot of expensive real estate. And you can also see this in some of the hurricane and typhoon figures as well. There's Hurricane Dorian that absolutely trashed the Bahamas in September. $11.4 billion worth of damage, $15 billion for Japan from Typhoon Hagibis in September, October. Compare that to the $2 billion estimated damage from Cyclone Idai, which hit the southeast of Africa during the earlier part of the year. All three of those were relatively similar intensity storms, but of course affecting very different areas. So developed areas in Japan and in North America, very undeveloped areas in Southern Africa. So yes, the financial cost very different, but of course what these figures don't measure is the human suffering that resulted. It also doesn't measure the damage to the natural world, the Australian fires, for example, pushing some species there close to extinction, or the pollution from flood runoff from some extraordinary rainfall events through the year, and particularly in developed areas as that runs off through watercourses and out into the sea, taking the pollution with it. So how does 2019 rank globally? Well, it was actually the second warmest year on record, behind 2016. But 2016 was boosted by quite a strong El Nino. It's 1.1 Celsius above the pre-industrial average. That figure, a result of the figures from the five main centres that monitor these things, Hadley Centre, NOAA, and so on. 2019 rounded off the warmest decade on record, and it's worth noting as well that all 10 hottest years globally have all occurred since 2005. So I think there's a very clear trend showing up there. But of course, there was a lot of variation regionally. Here we're looking at how temperatures varied across the globe. So the reddest areas showing record warmest year. If there were any deep blue areas, record coldest. There weren't any of those, but what does show up is North America, actually cooler than average. In fact, North America was the only continent that bucked the trend. It was the only continent where 2019 didn't rank in the top three warmest years. However, it was the warmest year on record in Alaska. It was the warmest year on record in Australia. Other notable areas, notable warmth, Eastern Europe showing up there. Many parts of Southern Africa, also parts of New Zealand were notably warm. Probably worth mentioning that ocean heat content was at a record level in 2019 globally. A severe ocean heat wave was registered in the Northeast Pacific. And you can see here the signature with this warm area in the Indian Ocean of the Indian Ocean Dipole. It's a similar sort of effect to El Nino, where temperatures are high temperatures wash back and forth from one side of the Indian Ocean to the other. That particular warmth in this phase over the western side of the Indian Ocean helped to fuel severe cyclone activity in that area. It also contributed to the Australian drought because when sea temperatures are relatively lower over the eastern side of the Indian Ocean, that tends to suppress rainfall but enhances rainfall where the temperatures are higher further west. And in fact, 2019 was Australia's hottest and driest year on record. Highest temperature of all through the year was at Nullarbor in the south of Australia here, 49.9 Celsius in December. That was actually just shy of the all-time record of 50.7 Celsius, which was set back in 19. Looking at rainfall across Australia, driest year on record. The average across the country came out at 277.6 millimetres, significantly below the previous driest of 314.5, which was set all the way back in 1905. But you can see quite large variations across the country. The red areas driest, of course, lowest on record, in fact, the deep red areas. But you'll also notice there's some big blue areas up across particularly northern Queensland. These were the result of slow-moving tropical low-pressure systems during the first quarter of the year and actually led to some fairly serious flooding. But of course, the hot and the dry weather elsewhere did contribute to some pretty catastrophic bushfires early and late in the year. Okay, staying with the heat and moving a bit closer to home. And the summer, of course, brought two major heat waves across Europe in late June and then again late July, which resulted in all-time temperature records for France, Germany, Belgium, Netherlands, and the UK. And we'll hear a bit more about that during today from another speaker. That French all-time record is from June, in fact, from the June heat wave. And you can see that in brackets is the previous record high from the 2003 heat wave, and it absolutely smashed that. In fact, temperatures in France in June were more typical of Death Valley in August. The other records were from the July heat wave. Reading around that temperature in Germany is from a site called Lingen, and it seems to be a little bit controversial. Apparently, despite being an official station, it's known to have a rather poor exposure. But worth noting that for the Netherlands and Belgium, that was the first time that they have recorded a temperature above 40 degrees Celsius. Now, in my life as a BBC weatherman, those heat waves are the sort of occasions that would prompt the question from the news presenter. So come on, tell us, is this climate change? Well, the answer then had to be that we couldn't really pin a single event on climate change, but it was an indication of what we expected to see more of in a warming world. That was a fairly stock answer. But now that's changed. The World Weather Attribution Partnership is an international effort that's been set up over the last couple of years to analyse and communicate the possible influence of climate change on extreme weather events such as storms, extreme rainfall, heat waves, cold spells and droughts. But crucially, within a few days of the actual event and while it's still fresh in people's minds and still in the news. And they use a combination of techniques. They apply statistical techniques to observation data sets, but they also use climate modelling with and without the effects of extra greenhouse gases. And that all lets them quantify the contribution of human-induced climate change to those particular weather events. Now, a number of World Weather Attribution scientists just happened to be at a conference on climate change and extreme events in Toulouse at Meteor France when that June heat wave occurred. So of course they got to work straight away and put out some comments on that. So actually that's from the June heat wave. They worked out that it was probably made at least 5 times more likely, and that was the lower bound of expectations, and also around about 4 Celsius hotter as compared to, we're talking about the period around 1901. For the July heat wave, they worked out that it was a rare event, really, even in today's climate for France and the Netherlands. So it really was quite extraordinary, even with the moving baseline. And also that such temperatures would have had extremely little chance to occur without human influence on climate. And I've added the link in there, so if you want to go and have a look for yourself at those reports, they're well worth a read. The year wasn't all about heat, though. We saw a breakdown of the Arctic polar vortex across North America in late January and February, which led to a pretty severe cold wave, which started in the east and then slowly extended its way further westwards. Periods of dangerously low wind chill values for central, eastern Canada and the USA, and also widespread snowfall. In fact, Ottawa had its snowiest January on record, and Vancouver its coldest February ever, as the emphasis gradually shifted west. And then further south in Los Angeles, the poor dears, it was the first time in their 142-year observation history that the temperature actually failed to reach 21 Celsius during February. Now, as I say, that was all down to cold air escaping from the Arctic, but the Arctic Ocean was still showing unmistakable signs of a warming world in terms of sea ice extent. So the September sea ice minimum, which we're seeing here, was equal second with 2007 and 2016. Not as low as that exceptional ice loss year of 2012, but there were a lot of slightly peculiar weather factors involved in that one, which pushed a lot of sea ice actually out of the Arctic. The maximum sea ice extent at the end of the winter was the 7th lowest in the satellite record, which goes back to the late 1970s. So not exceptional, but still part of the general downward trend. It's interesting to look at that longer term trend. Overall, it is clearly downwards. But after what seemed like a very rapid decline at the start of this century, recent years have perhaps seen some sort of levelling off. But I think it's important to point out that very little multi-year ice is now surviving compared to what you would have seen last century, and certainly compared to what you've seen before that. Multi-year ice is much, much thicker, it's much more robust, whereas most of what we see surviving now is very often just single-year ice, which is then much more vulnerable to melting due to weather events from storms or incursions of warm air. Okay, so let's have a look at global precipitation now. And well, it was certainly an exceptionally wet year for central and eastern parts of the USA, as you can see from this cluster of blue dots. And actually, it was the second wettest year on record when averaged across the whole of the USA. That led to record flooding along the Mississippi and the Missouri rivers, thanks to rain from persistent, slow-moving weather fronts, combined with rapid snowmelt from all that snow that had built up from the cold spell during the latter part of the winter. Notice notably dry across central, eastern, some southern parts of Europe. That wasn't a good combination with the heat wave, and probably partly responsible for that as well. Also notice quite a lot of dry conditions down across parts of Southeast Asia, and of course, as mentioned already, driest year on record in Australia. And again, we're back to that phase of the Indian Ocean dipole, tending to produce rather dry conditions across the eastern side of the Indian Ocean. Now, I've picked out a couple of the especially remarkable rainfall events from the year. Here we're in New Zealand, late March. We're on the South Island at Crop River. 1,086 millimetres of rain fell in the space of just 48 hours. That was a new national record for 48-hour rainfall in New Zealand. Slow-moving weather front here, moving up from the southwest, coming up against the western slopes of the Southern Alps, the South Island of New Zealand. Classic orographic enhancement due to uplift over those western slopes. I mean, they're used to rain here, but not used to these sort of amounts of rain. It's really quite extraordinary. Over a metre of rain falling in the space of 48 hours. Then we go to Japan for a new record 24-hour rainfall total for Japan. And this was thanks to Typhoon Hagibis, October the 12th, 922.5 millimetres in 24 hours. Absolutely extraordinary. Devastating flash floods as a result. That typhoon actually affected the Rugby World Cup tournament, you might remember as well. And Hagibis was actually one of the most rapidly intensifying tropical storms on record. And of course, you probably know you're going to hear more about tropical cyclones in 2019 from one of the talks later on this afternoon. But just as a reminder before that, looking at Hurricane Dorian now, which absolutely flattened the Bahamas in early September. It was actually the most intense hurricane ever to hit the islands, and at one point had sustained winds of 185 miles an hour, which is just unimaginable, I think, the sort of weather that we experience in the UK, and still trying to recover from the devastation caused by that even now. And then earlier in the year, Cyclone Idai, which struck the southeast of Africa, initially forming just as a tropical depression. It moved inland over Mozambique, wandered into Zimbabwe, Malawi. Not a strong storm, but because of slow movement, produced huge amounts of rain, wandered back out over the Mozambique Channel, and then really started to pick up intensity from those warm waters before running on into Mozambique as a pretty intense storm. Remember, the waters of the Western Indian Ocean, particularly warm due to that phase, again, of the Indian Ocean dipole. Around 1,300 confirmed deaths in Mozambique, over 2,000 people missing, 3 million people impacted, again, mostly in Mozambique. It actually turned out to be the second deadliest cyclone on record for the Southern Hemisphere. So a really remarkable event. Now, before I finish, let's have a look at one of the big drivers behind some of these severe weather events, which is, of course, atmospheric carbon. And this chart here shows annual atmospheric carbon dioxide increases from the measurements at Mauna Loa in Hawaii. The accumulation actually of CO2 in the atmosphere in 2019 was a little bit less than the peak years of 2015 and 2016, despite the fact that actual estimated emissions in 2019, 30 gigatons, were the equal highest with 2018. I suspect what we're seeing here is the overlay of record emissions on top of natural variation, with the natural processes in the carbon cycle managing to perhaps remove slightly more CO2 from emissions during 2019 than in 2018. An example of the complexity of the science in this regard. Regardless of that, we still ended up with more CO2 in the atmosphere at the start of 2020 than we had 12 months previously, 413.4 parts per million. Bear in mind that pre-industrial concentrations were around 280 parts per million. I think also nice to point out from this graph, this is a running mean, the black line, but this is the actual sort of monthly variation through the course of each year. And you can see a very definite annual cycle, overall trend upwards, but that annual cycle, which is caused by the seasonal change in vegetation across the northern hemisphere. So if we start at the peak here, for example, let's start up here. So here we are in spring, just as the spring growth cycle begins. CO2 levels at their highest. As all that spring growth kicks into action, all the plants start to take in CO2 and lock it up. Trees in the wood and so on in their leaves, the grass in its leaves as well. And so the CO2 concentrations actually come down during the growing season. But then we get to the autumn The growth dies back, or the leaves fall off the trees, the grass, the herbaceous plants all die away, and then through the latter part of the autumn and over the winter, then all that carbon is released back into the atmosphere again as the plant matter actually decays. And so you get this wonderful annual cycle, which I like to think of as the sort of heartbeat of the planet. Finally, I think probably one of the legacies of 2019 is really a step change in the awareness of the serious threat of human-induced climate change. Partly, I suspect, down to the weather events that I've mentioned, which were never out of the news, but certainly because of better communication and much more media exposure. The World Weather Attribution Team have certainly played a part in that, with that rapid response, able to link a particular event very quickly to the climate change contribution. The BBC has moved very significantly as well to recognise the science as being settled, as demonstrated by the Attenborough documentary Climate Change, the Facts, being screened at prime time. And there's no doubt that activists like Extinction Rebellion and Greta Thunberg have really pushed climate change right up the agenda with remarkably high levels overall of public support. In fact, a recent survey found that a sample of the British public put climate change in the top 2 problems currently facing the country. Also, I have to say that was before coronavirus took hold. Well, that's it for me. Clearly, I can't offer to take any questions, but I hope you very much enjoy the rest of the event today. Thank you very much.